Okay, greetings one and all, and welcome to this math video. In this math lesson, we will be considering the topic mensuration. Let's begin. Okay, this question says the rectangular playground design shown below consists of a lawn and two equal semicircles of concrete. And so here we have a lawn. This part right here is the lawn, all right? The one that is shaded, that's the lawn. All right, and on the outside right here, we have the concrete, and the concrete has the shape of a semicircle, and this other concrete has the shape of a semicircle, right? Um, this right here, the length is 20 meters, and the width is going to be 14 meters. And here, they told us to use pi as 22/7, and they want us to calculate the perimeter of the lawn. Now, perimeter is basically the distance around the shape. That's what the perimeter is. And so in order to find the perimeter of the shape, in order for us to find the perimeter of the lawn, we have to first consider this portion, right? That portion. So the perimeter of the lawn, let's represent the perimeter of the lawn in red. So the perimeter of the lawn is going to be this side, which is 20 meters, all right? And that's how we get the 20 meters right there. And it's also going to be this side, that's also part of the lawn, okay? So if the top part is 20 meters, then the bottom part is also going to be 20 meters. So that's why we have the 20 meters there. And we also have this curved portion. So the curved portion of the lawn, that's going to be represented by pi r, okay? Pi r for this curved portion. That's the formula for the curved portion of a semicircle. And then the curved portion right here, right? The curved portion right here is also pi r, all right? And so we have this curved portion, all right? So we have in total, we have 20 meters, right? 20 meters plus the curved portion, which is pi r, plus 20 meters again, plus the curved portion again, which is pi r, all right? Now, when we say pi r, we mean pi multiplied by the radius, right? In this case, the radius is going to be half of the distance of this concrete, right? So half of it. Now we know that the total thing, so the radius again is going to be half of it. Now we know that the total thing is 14, right? The total distance is 14. So in order for us to find the radius, right, the radius is going to be equal to 14 meters divided by 2. All right, so 14 meters divided by 2. And what is 14 divided by 2? Well, that's definitely going to be 7. So the radius is going to be 7. So let's plug it in. So we have 20. So we have 20 plus 22/7, that's pi, times r. R is 7 plus 20 plus pi r. Pi r is 22/7 times 7, all right? Now what we're going to do in this case, we're going to cancel out the 7s. So let's cancel the 7. This 7 cancel with that 7. That 7 cancel with that 7. So we're left with 20 plus 22 plus 20 plus 22. And that's going to give you 84 meters. So the perimeter of the lawn is definitely 84 meters. And the reason why that's the case is because if you add 20 plus 22, again, if you add 20 plus 22 plus 20 plus 22, your answer is definitely 84. All right, let's move on to the next question. It says fencing is sold at 40 cents per meter. Calculate the cost of fencing the lawn. So in order for us to find the cost of fencing the lawn, we just have to multiply our 84 meters because it's 84 meters for the entire lawn. That's the distance of the lawn. And so if we know that each meter is $40.75, we have to multiply 84 by 40.75. And we multiply 84 multiplied by 40.75, we indeed get 3,423. And that's the cost of fencing the lawn. Okay, let's move on to the next question. Okay, we got that. So the next question asks us to find the area of the lawn. All right, the area of the lawn. So the area of the lawn, now this is not the perimeter, we're looking at the area. The area of the lawn is going to be, basically they want the area of the shaded region, right? So they want this area, the area that I'm shading in red. So they want to know the space that's inside of it. How much space is inside this lawn, right? That's the area, right? Not the distance around it. We just calculated that that was the perimeter. But here we want the area, right? how much space is inside this, right? So in order to do this, the first thing we're gonna do is we're gonna find out, and it's an interesting way we're gonna do it. We're gonna find out the perimeter, not the perimeter, we're gonna find out the area of the total rectangle, the total area of the rectangle, right? And then we're going to subtract that by the area of this semicircle and the area of that semicircle. And it makes sense because if we remove or if we subtract the area of the concrete and the area of this concrete from the total area of the box, if we like remove it, then the only thing that we're left with is the area of the lawn. So that's how we're going to find out the area of the lawn. And so the area of the rectangle, let's first find that out. That's going to be 20 meters. 20 meters length times width multiplied by 14 meters. And that gives us 280 meters squared, right? And that's how we find the area of the rectangle. And then in order to find the area of the concrete, what we need to do is we're going to say pi r squared. Reason we say pi r squared because it's the area of a circle. You may say, why we use the area of a circle? Well, we have two semicircles. So this semicircle and that semicircle, when you combine them, they give you a circle. So we just use the area of a circle. So pi r squared, what is pi? Pi is 22 over 7. What is the radius? The radius is 7. And so we have pi r, so we have 22 over 7 multiplied by 7 squared. And so we have 22 over 7 multiplied by 49 because 7 squared, which is 7 times 7, is 49. What we're going to do here is I'm going to multiply 22 by 49 to get 1,078. And 7 times 1 is 7. And then I divide 1,078 by 7, which gives me 154 meters squared. Okay, so that's the area of the lawn, the area of this shaded region. Okay, let's move on. Oh, I'm sorry, that's not true. This is the area of the concrete. So we found the area of the concrete, and we found the area of the rectangle. So now in order to find the area of the lawn, we have to subtract. And so the area of the rectangle, 280 meters squared minus 154 meters squared. So we subtract them and we get 126 meters squared. And that's going to be the area of the shaded region, the area of the lawn. Because we take the area of the rectangle and we subtract it with the area of the concrete, and that gives us the area of the lawn. Okay, let's move on to this next question. Here it says, the template below consists of a semicircle and a right angle triangle. So here they want us to figure out the length of the diameter AC. And so the diameter AC right here, this one right here, that is a part of this triangle. It is a right triangle, so we could use Pythagoras theorem. This is the longest side, so that's definitely the hypotenuse, which is C, right? So the formula we're going to use here is C squared equals to A squared plus B squared. Now, A is going to be 8, that's one side of the triangle, and B is going to be 6 because that's the other side of the triangle. And so we say C squared is equal to A squared plus B squared. That's Pythagoras theorem, which we're using to find the length of AC. All right, 8 squared is definitely going to be 64, and 6 squared is definitely going to be 36. We add those two together, we get 100. In order to find out what C is, we're going to take the square root of both sides, and we're going to cancel out the square root with the square, leaving us with C is equal to the square root of 100. And we know that the square root of 100 is 10, so that means that AC is going to be equal to 10, all right? Okay, let's move on to the next question. Here, we want to figure out the area of the triangle. So we're looking at this triangle. Now, if we consider a triangle, the formula for area of a triangle is base times height. 6 is the base and 8 is the height. And so we're going to multiply 6 times 8. Again, 6 is the base and 8 is the height. And so 6 times 8 is 48. We divide that by 2 and we get 24 units squared. Now we say units squared because they don't give us if it's centimeters or meters or inches. So they don't give us no units. So we just put units squared because we don't know what units they're talking about. But whatever it is, whatever unit it is, it's going to be unit squared because area is always a unit squared. Whatever unit you're talking about, square that. Okay, so now we want the area of the semicircle. So the formula for the area of a semicircle is pi r squared divided by 2. Now, what is the radius? Well, we know that AC, we just found out what AC was. AC is the diameter of the semicircle. Now, AC is 10 units. So half of that, half of 10 is going to be the radius. So the radius, remember the radius is half of the diameter. So the radius is going to be 10 divided by 2. Okay, so 10 divided by 2, which is going to be 5. All right, and so that means that we have 3.142. That's pi, all right, over 2, right? Multiplied by r squared. R is 5. When you square that, you get 25. And so we have 3.142 over 2 multiplied by 25 over 1. We multiply 3.142 times 25 to get 78.55. Multiply 2 by 1 to get 2. Then we divide 78.55 by 2 to get 39.275 units squared. And that's going to be the area of the semicircle. Now they want the total area of the template. All we need to do is add the area of the semicircle plus the area of this triangle. When we add them, we get the total area. So the area of the triangle is going to be 24, which we saw earlier. The area of the semicircle is 39.275. When we add them, we get 63.275 units squared. Okay, let's move on to the next question here. They want us to figure out the volume of this canister. Now this has a cylindrical shape. The diameter is 7 centimeters and the length is 20 centimeters in length. So what we're going to do is we're going to consider the formula for volume of a canister. I'm sorry, we're going to figure out the formula for volume of a cylinder. Now the volume of a prism is cross-sectional area, or the area of the cross-section multiplied by the length. In this case, the area of the cross-section, right? The area of the cross-section is a circle, right? The area or the formula for the area that we should use is the area of a circle, because the cross-sectional area, the cross-section of this cylinder is a circle. So the area of the cross-section is going to be pi r squared. And so it's going to be pi r squared multiplied by the length. Okay. Now that's the volume of the cylinder, pi r squared multiplied by the length. Now we know pi is 3.14, and we know that r, which is the radius, is going to be half of 7, right? Half of 7. What is half of 7? That's going to be 3.5. And so we say r squared. So 3.1, sorry, my bad. So we have pi is 3.14. We have 3.5. The reason why we got 3.5 is because we divided 7 by 2 to give us 3.5, because half of 7 is 3.5. And so we say 3.5 squared multiplied by the length, which is 20. And then we square 3.5. So 3.5 squared, and we multiply it by 3.14. And we multiply our answer, which we got 38.465, and we multiply it by 20 to get 769.3 centimeters cubed. It's important to note that it's centimeters cubed because the area is centimeters squared plus multiplied by the length, which is in centimeters. So centimeters squared multiplied by centimeters is going to give us centimeters cubed. So volume is always units cubed. Area is always units squared. Okay, so now we want to figure out the number of canisters to be purchased. They said that one canister contains 425 grams of sealant. A window sealing job requires 1.8 kilograms of sealant. The first thing that we notice is that the units are not the same. So 425 grams and 1.8 kilograms, their units are not the same. So let's try to make sure that our units are the same. So let's convert 1.8 kilograms to grams. We use our acronym, knock him down, Grammy, don't commit a murder. And we're moving from kilograms to grams. So we're going to move in that direction to the right. So we move how many times? 1, 2, 3. And so what that means is that we're going to multiply 1.8 times 1,000 to get 1,800. So 1.8 kilograms is 1,800 grams. Okay, so now we know that the window sealing jars requires 1,800 grams of sealant, and one canister of the sealant is 425 grams. So we're going to divide 1,800 by 425, and we get 4.235294118. Now, in order to figure out the number of canisters to be purchased, we would say that the number of canisters to be purchased is 5 canisters, because the reason why we say 5 canisters is because we have 4.235. That's our exact answer. But when we're looking at the number of canisters, we can only deal with whole numbers, right? Because you can't have 4.235 number of canisters. These are whole stuff. So you could have 1 of them, you can have 2 of them, you can have 3 of them, but you can have 4 of them, or you can have 5 of them, but you can't have 4.235 of them, right? They are whole stuff, right? Just like bags of cement, right? You have 1 bag of cement, the next bag of cement, the next bag of cement. You can't have 4.235 bag of cement, right? It's a decimal. We're only looking at whole bags, right? And so that means that if we try, so it's either we're gonna get 4 or we're gonna get 5, right? If we say we're gonna get 4, the problem is it's not gonna be enough. So we need to get 5 bags of canisters. So we need to get 5, we need to purchase 5 canisters, because if we purchase 4, it's gonna be too little. And if we purchase 5, it's gonna be more than enough, but it's gonna be enough to cover all our needs, and plus leave with rest, leave with some, because we can't get, it's either getting 4 or 5, right? There's no 4.235 number of canisters, right? It's either 4 or 5. Which one you're gonna pick? But we have to pick 5 um because we have to pick 5 because if we pick 4, it'll be too little. All right, we won't have enough to do the window sealing job. All right. Okay, so let's move on to the next question. Okay, so here it says the diagram below shows the cross-section of a culvert 6.2 meters wide and 3 meters high, with a semicircular opening of diameter 5.6 meters. Calculate using pi as 22/7 where necessary the perimeter of the cross-section. Well, let's first lay out or outline the perimeter of the cross-section. So here, the first thing we notice is that we can go in this direction. So this is going to be 3 meters, right? So that's 3 meters. The next part is we're going to go this direction. That's going to be 6.2 meters, right? So we just, outlining the area, the perimeter, the lengths that we're using. And if this side is 3 meters, they're equal in length. So this is going to be 3 meters, all right? And the length of the curved portion of a semicircle is going to be pi r. So this is pi r, okay? And that's why we have pi r here, okay? Now, this portion right here, let me put this portion in another color, this portion right here. This portion right here is going to be this, right? And this portion right here is going to be this, right? So that's how we represent it. Now, why did we do that? Well, if you notice carefully that the whole thing is the length 6.2. So that means that the whole thing, I made it denoted in green, the whole thing, right? The whole thing is 6.2, right? The whole thing. But what we do know is that from this end to this end, it'll be 5.6. So we do is we subtract 6.2 with what? 5.6 meters, all right? And so that leaves us with the sets in baby blue, right? That leaves us with the length of baby blue when we subtract 6.2 and 5.6. But then we divide it by 2 because that quantity, that length is shared between this side and that side. And so that means that this baby blue side is represented by this 6.2 minus 5.6 divided by 2. And this blue side right here is represented by this 6.2 minus 5.6 divided by 2. Okay, so let's perform our calculations. Pi is 22/7. R, well, R is going to be, well, if we notice carefully, let me erase all ink. R is the radius, but this right here, right, the 5.6 is the diameter. So we have to cut it in half, right? So we say that R is going to be equal to 5.6, which is the diameter of the semicircle, 5.6 divided by 2. okay, divided by 2. When you do 5.6 divided by 2, you get 2.8. You get 2.8. And so that's why the radius right here, the radius is given by 2.8. Okay, so let's add. So we have 3 meters, 6.2 meters, 3 meters, 22/7 times 2.8 is 0.3 meters and 0.3. And so when we add, before we add, let's multiply. So I multiply 22 times 2.8 and divide it by 7, and I got 8.8 meters. And when we add all these together, we get 21.6 meters. And so that means that the perimeter of the cross section is 21.6 meters. Okay, let's move on to the next question. Here we want the area of the cross section. Now, if you look carefully, in order to find the area of the cross section, what we need to do is we need to first figure out the area of this rectangle. So if we were to close it up, right, we could notice that this whole thing is a rectangle. So that means that the first thing we need to do is we need to figure out the area of the rectangle. Now, once we get the area of the rectangle, if you notice carefully, that there is a semicircle we could carve out, right? A semicircle right now. There's a semicircle that we could carve out. And what we need to do is, once we could find the area of this semicircle, the one in green, right? And remove it out of the picture, like pull it out or subtract it out, then we'll be left with the area in red, right? The area that is on the outside. We'll be left with that area on the outside. And that's going to be the area of the cross section. So what we need to do is we need to find the area of the full rectangle, and then we're going to subtract that from the area of the semicircle, and that's going to give us the area of the cross section. So let's do that. So first, let's figure out the area of the rectangle. The area of the rectangle is length times width, which is going to be 6.2 multiplied by 3, and that gives me 18.6 meters squared. Now let's figure out the area of the circle. The area of the semicircle rather. Well, the area of the semicircle is going to be pi r squared divided by 2, where pi is 22/7, right? And this is pi r squared divided by 2. Now, pi is represented by 22/7. 1/2, the reason why I have 1/2 is because we're dividing by 2, which is basically like multiplying by a half. Then we have r squared. Well, r squared is 2.8 to the power of 2. And so what we're going to do here is we're going to multiply 22 times 1 is 22. 7 times 2 is 14. Then we have 2.8 squared. Or what we're going to do is we're going to raise 2.8 to the power of 2, which is 7.84. Then we multiply 22 times 7.84 is 172.48. Divided by 14, we get 12.32 meters squared. So this is the area of the semicircle. This is the area of the rectangle. And so what we're going to do is we're going to subtract them. And so the area of the cross section is going to be equal to 18.6 meters squared, which is this 18.6 meters squared, minus 12.32 meters squared. And so when we subtract them, we get 6.28 meters squared. And that's going to be the area of the cross section, the difference between the area of the rectangle and the area of the semicircle. Okay, let's move on to this question. For this one, it says that the diagram represents a triangular prism of length 19 centimeters. The triangular cross section has sides of a length 10 centimeters, 11.3 centimeters, and 14 centimeters, and a height of 8 centimeters. Here we want to figure out the area of the cross section. Well, the cross section for this particular shape is a triangle. So we want to find out the area of the triangle. That's basically what they're trying to say. So let's figure out the area of the triangle. Well, area of the triangle is going to be equal to base times height divided by 2. The base is definitely 14 and the height is 8 centimeters. And so we're going to multiply those two. 14 centimeters multiplied by 8 centimeters is going to be 112 centimeters divided by 2. When we divide it by 2, we get 56 centimeters squared. And that's the area of the cross section, or the area of the triangle. All right, now we want to find the volume of the prism. Well, volume of a prism is going to be equal to cross-sectional area of the cross-section, multiplied by the length. Now the length in this case is going to be 19 centimeters. And the area of the cross section, well, that's what we figured out in part A. We figured out the area of the cross section, or the area of the triangle, which we found out to be 56 centimeters squared. Now we're going to multiply that with our length, which is 19 centimeters. And so when we multiply that, we get 1,064 centimeters cubed, and that's going to be the volume of the prism. Okay, now here they want us to figure out the total surface area of the prism. Now, in order to figure out the total surface area of the prism, we have to figure out the area of each of the two-dimensional shapes that make up this three-dimensional prism, right? So we have to find out the area of each of those two-dimensional shapes that make up this three-dimensional figure, and then add them all up. So let's first deal with the area of the front triangle. And so by the area of the front triangle, we're talking about this particular triangle right here, right? This one. We're talking about this triangle. That's the front triangle. Now, in order to find that, the area of that, we just figured that out. That's going to be the base, which is 14, multiplied by the height, which is 8 centimeters. And that's definitely 56 centimeters squared. So 14 centimeters multiplied by 8 centimeters divided by 2 is 56 centimeters squared. That's the first triangle, right? The first one. Now we need to figure out the area of the triangle in the back. And indeed, there's a triangle at the back. If we were to complete this image, so we were to try to complete it, this image, we would see that there is indeed a triangle at the back. So yeah. All right, trying to complete the image. So you're trying to imagine a three-dimensional figure. So good. So now we're looking at the area of the triangle in the back, right? The area of the triangle in the back. Now, the area of the triangle in the back, well, if we look carefully, its height is going to be the same height as this one. So the height right here of this triangle in the back is going to be 8 centimeters, okay? And the base is going to be the same, right? The base is going to be the same as this one. So the base is going to be 14 meters, all right? And so 14 centimeters rather. So that means that the area of the triangle at the back is going to be 14 centimeters times 8 centimeters, base times height, divided by 2. So both of them are going to be 56 centimeters squared. So the area of the triangle in the front and the area of the triangle in the back are the same. Okay, next, what we need to do is we need to figure out the area of the triangle, sorry, the area of the bottom rectangle. Okay, so there is a rectangle at the bottom. So if we look carefully, we're considering this rectangle at the bottom, the one at the bottom. So we want that one. That's one of its sides. This is the next one of its sides. The one at the bottom. Okay, so we're looking at this one. Okay, so this same rectangle right there. All right. So what is the area of this rectangle? Okay. That's what we're trying to figure out. Now, in order to find the area of this rectangle, it's going to be length times width. The length of it is definitely 19, right? And the width is 14 centimeters. So we do 19 times 14, which gives us 266 centimeters squared. But it's still not done. We still have some more parts to do. So let me erase this. We still have some more parts to do. So, all right. So the next part that we want is we want the area of the right rectangle. Okay, the area of the rectangle to the right. And so let's use a color for this. Let's use another color. So what we're gonna do is we're looking at this rectangle right there, the same one, the one to the right. All right. So this one, and it has a top here part right there, and it has a bottom part right there. And so we're looking at the area of this same rectangle right there, this one. Now, if you look carefully at this rectangle, you would notice that its length and its width is, the first thing for when we consider the length, it's going to be 19 centimeters. So its length is 19 centimeters right here. And then its width is going to be 11.3 centimeters. So length is 19 centimeters and width is 11.3. And so that's how we get 214.7 centimeters. That's the area of the triangle on the, sorry, that's the area of the rectangle on the right. Okay, let's move on. Now we want the area of the rectangle on the left. So what does that mean? We want the area of the rectangle on the left. So let me move this, all of this, all of this, all of this, all of this. We want the area of the rectangle on the left. So we're considering this one, this same one right there on the left hand side. Goes up like that, and comes down. So if we're looking at this, if we're looking at this rectangle, let me shade it in right now. And so the idea is that we want to figure what its length is, what its width is. So its length is going to be also 19 centimeters, right? Because those two are the same, right? Its width is going to be 10 centimeters right now, because this is 10. So its length is 19 and its width is 10. And so we have 19 times 10, which is 190 centimeters squared. Okay, now what we need to do is we need to find the total surface area of the prism. And the total surface area of the prism is going to be 56, which is this one, plus 56, which is that, plus 266, which is that, plus 214.7, which is that, plus 190. All right, and so when we add them all up, we get the total surface area of the prism, and the total surface area of the prism is going to be 782.7 centimeters squared. And that's going to be how we get the total surface area of this prism. Okay, let's move on to this next question. Now, for this next question, we want to figure out the area of the cross section. And so here we have an isosceles trapezium. Sorry, they said that the cross section is an isosceles trapezium of parallel sides, 54 centimeters and 24 centimeters with slant sides of length 25 and height 20 centimeters. So if we want the area of the cross section, right? Remember, the area of the shape that we're dealing with is trapezium, right? An isosceles trapezium. So the formula for the area of a trapezium is going to be half A plus B times H, right? Now, A, if we look carefully, A is going to be, so this right here, this length right here. But first, let's draw out the trapezium. So this right here is the trapezium, right? This right here is the trapezium. That's the cross section. That's the cross-sectional shape. Now, we want to figure out the area of this trapezium. So we need the height, this part right here, right? This part right here. That's definitely the height, which is 20 centimeters, and that's why we have 20 centimeters here. We also need A and we also need B, right? B is going to be the base, so that's going to be this one, 24 centimeters. That's why we have 24 here. And A is going to be the length of the top part, which is 54 centimeters. Because if this is 54, then this part is also 54, right? So we have 54 centimeters. So what does that mean? That means that 20 centimeters is the height, 24 is the length for B, and 54 is the length for A. Okay, now let's add it. 54 plus 24 is going to be 78. 54 plus 24 is going to be 78. So 54 plus 24 is 78. And so we have a half times 78 times 20. So again, a half times 78 times 20. So what we're gonna do, we're gonna multiply. What is a half? A half is 0.5. So we have 0.5 times 78 times 20. Again, 0.5 times 78 times 20. When we multiply that out, we get 780 centimeters squared. 780 centimeters squared. So the area of the cross section is going to be 780 centimeters squared. Okay, now the next part is we want the volume of it. So the volume, remember the volume of a prism is going to be cross-sectional area multiplied by the length. And so the volume is area of the cross-section multiplied by the length. So what did we get for the area of the cross-section? The area of the cross-section is 780 centimeters squared multiplied by 80 centimeters, which is going to be the length. And so when we multiply them together, we get 62,400 centimeters squared. And that's the area, and that's the volume of the trough. Okay, that brings us to the end of this video. I will see you in the next video where we're going to explain the other parts of this question. I think it's only one more part of this question, and then we're going to continue with the other years. All right, see you in the next video. Take care.